Today's problem is two-sum. You are given an array of integers called nums, and an integer called target. Your task is to find two different numbers in the array such that their sum is exactly equal to the target value. Instead of returning the numbers themselves, you need to return the indices of those two numbers. You can assume that each input will have exactly one valid solution, and you are not allowed to use the same element twice. The order of the indices does not matter, so you can return the answer in any order. That's the full problem statement. Now let's move on to understanding how to solve it efficiently. Let's understand the problem with a few examples. Example 1. The input array is 2, 7, 11, and 15, and the target is 9. If we add the numbers at index 0 and index 1, that is 2 plus 7, we get 9. Since this matches the target, we return the indices 0 and 1. Example 2. The input array is 3, 2, and 4, with a target of 6. Here, the numbers at index 1 and index 2 add up to 6. So the correct output is indices 1 and 2. Example 3. The input array is 3 and 3, and the target is 6. Adding the numbers at index 0 and index 1 gives us 6. Even though the values are the same, the indices are different, so this is valid. We return 0 and 1. These examples show that we are always looking for two different indices whose values add up to the target. Let's understand this problem using a simple example and a whiteboard-style explanation. We are given an array of numbers 2, 7, 11, and 15. And we are also given a target value, which is 9. Our goal is very clear. We need to find two different indices such that the values at those indices add up to the target. There is exactly one valid answer, and we are not allowed to use the same element twice. So that means we must pick two different positions in the array. Let's start from the first number. We take the value at index 0, which is 2. Now we ask a simple question. What number do I need to reach the target 9? 9 minus 2 gives us 7. Now we scan the rest of the array to see if 7 exists. At index 1, we find the value 7. Perfect match. That means nums 0 plus nums 1 equals 2 plus 7 is equal to 9. Since we found two numbers that add up to the target, we return their indices. The indices are 0 and 1. Notice that we return indices, not values. So the key idea here is simple. For each number, we ask, what number do I need to reach the target? If that number exists later in the array, we return the two indices. This exact logic is what we later optimize using a hash map. Now that we clearly understand the example, let's move on to the optimized solution and see how we can solve this efficiently in one pass. Now, we create a dictionary called num_map. This will store numbers we have already seen along with their indices. The key idea is simple. Store first, check later. Now we loop through the array using enumerate. This gives us both the index and the value at the same time. For every number, we calculate its complement. The complement is the value needed to reach the target. So we subtract the current number from the target. Now comes the most important step. We check if this complement already exists in the hash map. If it does, we have found our two numbers. If the complement is found, we return the index stored in the map and the current index. This guarantees we don't use the same element twice. If the complement is not found, we store the current number in the map with its index. This prepares it for future checks. And that's it. We scan the array once, store values as we go, and instantly return the answer when the match is found. Time complexity is O(n). Because we traverse the array only once. Space complexity is also O(n). Due to the hash map. This is the most efficient solution for the two-sum problem. Alright, now let's hit run code. Nice, all the sample test cases are passing without any issues. That means our hash map logic is working exactly as expected. Now for the real test. Let's click submit. And there we go, accepted. All test cases passed successfully. That's how you solve the two-sum problem efficiently using a one-pass hash map. simple logic, optimal performance, and clean code. If this explanation helped you, make sure to like the video and subscribe for more daily LeetCode solutions. I'll see you in the next problem. Happy coding!